Look up at the night sky. For nearly all of human history, those glittering points of light were just that. Lights. We knew of the planets in our own backyard, our celestial family orbiting our sun, but we were, in a cosmic sense, alone in our knowledge of worlds. That has all changed. In just the last few decades, our instruments have become sensitive enough to detect the subtle dimming of distant stars, the telltale sign that a planet is passing in front of it. We call these worlds exoplanets. And their discovery has opened up a new frontier, a sprawling galactic atlas of countless other solar systems. The universe, it turns out, is teeming with planets. But these are not just simple copies of Earth or Jupiter. The cosmos, in its infinite creativity, has forged worlds of such staggering strangeness that they defy our expectations and stretch the very limits of our imagination. We've found planets where it rains glass sideways, worlds made of solid diamond, and planets older than we thought possible. These aren't science fiction, they are real places, confirmed by the rigorous methods of science. Each one a testament to the universe's boundless potential for variety. So, come with me. Let's journey beyond the familiar shores of our solar system and voyage to the farthest, most bizarre outposts of the known cosmos. Together, we'll explore the 10 most peculiar, most mind-bending exoplanets that astronomers have discovered so far. Prepare to have your cosmic perspective expanded. The ship of the imagination is ready to depart. Our first stop brings us to a world locked in a cosmic dance of death. Meet WASP 12b, a hot Jupiter so close to its parent star that its year, one full orbit, lasts just over a single Earth day. This extreme proximity has superheated its atmosphere to over 2,200 degrees Celsius. But that's not its most peculiar feature. WASP 12b is pitch black. It's a cosmic void in the shape of a planet, absorbing at least 94% of the light that falls upon it. It reflects less light than fresh asphalt, a true ghost in the cosmic machine. The reason for its darkness is tied to its tragic fate. The immense gravity of its parent star is literally tearing WASP 12b apart. The planet is stretched into an egg shape as its atmosphere is continuously siphoned away, forming a massive, swirling disk of material around the star. This star is actively consuming its own planet, and the planet's heat is so intense that molecules like hydrogen are broken down into atomic form, preventing clouds from forming that might otherwise reflect light. It is a world being erased, a dark, silent scream in the void. Now, let's journey 63 light-years away to a world that looks from a distance deceptively beautiful. HD 18933b is a deep azure blue, reminiscent of our own tranquil Earth as seen from space. But do not be fooled by its inviting color. This is no welcoming ocean world. The blue hue comes not from water, but from an atmosphere laced with silicate particles. And the weather forecast here is something out of a nightmare. It rains glass, sideways, driven by ferocious winds that howl at over 8,700 kilometers per hour. Imagine that. Winds 7 times the speed of sound, whipping a perpetual storm of molten glass shards through the superheated air. The temperature on this gas giant is a scorching 1,000 degrees Celsius, hot enough to melt silicate into its liquid glassy form. The sheer violence of this world is almost incomprehensible. It's a beautiful blue marble that conceals a hellscape of unimaginable proportions, a stark reminder that in the cosmos, appearances can be lethally deceiving. This isn't just bad weather, it's a planetary-scale blender of wind and glass. Many of us have gazed upon the iconic twin sunset on the desert planet of Tatooine in Star Wars. It was a masterpiece of cinematic imagination, a vision of a truly alien sky. But science, as it so often does, has caught up with fiction. I present to you Kepler 16b, a world where that vision is a daily reality. This planet is circumbinary, meaning it doesn't orbit one star but two. Each day on Kepler 16b would feature the spectacle of a double sunrise and a double sunset. This world, about the size of Saturn, is a cold, gaseous place, unlikely to harbor life as we know it. But its existence confirms that stable planetary orbits can indeed form in binary star systems, a possibility once debated by astronomers. Imagine standing on a moon of this gas giant, watching two shadows stretch and shrink as the two suns, one larger and brighter, the other smaller and dimmer, trace their own distinct paths across the sky. It's a celestial ballet on a grand scale, a place where the fundamental rhythm of day and night is a complex, beautiful duet. You know, we measure wealth on Earth in fleeting things, but the universe deals in more permanent currencies. Let's travel to the star system 55 Cancri and visit its most precious gem, the planet 55 Cancri e. This super-Earth, which is about twice our planet's size and 8 times its mass, is thought to be a world of unimaginable riches. Based on its density and the chemical composition of its star, astronomers theorize that this planet is carbon-rich. And under the immense pressures and temperatures found there, that carbon could be compressed into a form we know and covet diamond. A significant portion of this planet's mass, maybe as much as a third of it, could be pure solid diamond. Forget diamond mines, this is a diamond world. Its surface might be a crust of graphite and other minerals, beneath which lies a thick global layer of diamond, shrouding a liquid carbon core. It's a vision of wealth so extreme it becomes, well, almost meaningless. This planet reminds us that the elements we consider rare and precious on Earth are, on a cosmic scale, just building blocks, capable of forming structures on a scale that really dwarfs our wildest dreams of fortune. We often search for worlds like our own, with oceans and continents. But what if a world wasn't just with oceans but was an ocean? Our next destination, GJ1214b, might be just that. This mini Neptune is larger than Earth, but smaller than our ice giants, and it has a remarkably low density for its size. The best explanation for this is that the planet is composed of a vast amount of water, not just surface oceans but a global ocean thousands of kilometers deep. The conditions on this world would be unlike anything in our solar system. The immense pressure at the bottom of this global ocean would be so great that it could form exotic types of ice, not from cold, but from compression, hot ice or ice 7. Above this deep dark ocean would be a thick dense atmosphere of steam and vapor, shrouding the entire planet in a perpetual humid haze. It's a world where the lines between ocean and atmosphere blur, a planetary-scale sauna of incredible proportions, a true water world in the most extreme sense of the term. The universe is old, about 13.8 billion years old. We tend to think of planets as relatively recent arrivals, formed alongside their younger stars. But our next subject challenges that notion profoundly. Meet PSRB 1620-26b, nicknamed Methuselah. This planet is estimated to be about 12.7 billion years old. It formed when the universe was just a billion years into its existence, making it one of the oldest, if not the oldest, exoplanet ever discovered. It's a true cosmic relic. Its story is as strange as its age. It orbits not one but 2 stellar corpses, a pulsar and a white dwarf. This unlikely trio resides in a dense globular cluster, a swarm of ancient stars on the outskirts of our galaxy. This planet has likely witnessed the entire history of our Milky Way unfold. It was already ancient when our own sun and Earth were just a cloud of gas and dust. Thinking about Methuselah forces us to reconsider when and where life could have begun. Could life have emerged on worlds like this, billions of years before Earth even existed? Planetary systems, we thought, were orderly affairs with planets orbiting their star in a relatively flat, stable disk. But, HD 106906b shatters that neat picture. This massive planet, about 11 times the mass of Jupiter, is on an orbit so vast and so strange it's honestly hard to comprehend. It orbits its star at a distance of more than 730 times the distance from the Earth to the Sun. If this planet were in our solar system, it would be almost 20 times farther out than Neptune, deep in the icy darkness of the Kuiper Belt. Its orbit is not only huge but also wildly tilted and elliptical, far from the plane where the system's other material resides. This has led to a fascinating theory. Perhaps HD 106906b didn't form there at all. It may have formed closer to its star like Jupiter did, and was then kicked out by a gravitational tussle with another massive object. It is, in essence, a rogue planet that was captured on the very edge of its own solar system, a lonely wanderer held by the thinnest of gravitational threads. It's a testament to the chaotic and violent dynamics that can shape a planetary system's history. The search for exoplanets is often framed as a search for Earth 2.0, and for a time, Kepler 438b looked like a prime candidate. It's a rocky planet, only slightly larger than Earth, and it orbits within its star's habitable zone, the region where liquid water could potentially exist on its surface. From a distance, it had all the right credentials. It was for a moment considered one of the most Earth-like planets we had ever found. A beacon of hope in the cosmic darkness. But proximity to a star is a double-edged sword. Kepler 438b's parent star, a red dwarf, is far more volatile than our Sun. It frequently unleashes powerful stellar flares, massive eruptions of energy and radiation. These superflares, sometimes 10 times more powerful than any recorded on our Sun, would regularly blast the planet, stripping away its atmosphere and bathing its surface in sterilizing radiation. So, while it might be the right temperature for life, it's in the absolute worst neighborhood. It's a tragic, what if, a potentially beautiful world rendered uninhabitable by the fury of its own star. We began with a dark planet, WASP-12b. Now we travel to a world that makes it look bright by comparison. Welcome to TRES-2b, officially the darkest exoplanet ever discovered. This is a world of profound, almost absolute blackness. It reflects less than 1% of the starlight that hits it, making it darker than coal, black paint, or any substance we're familiar with on Earth. If you were floating in space next to it, it would be almost impossible to see, a hole in the fabric of the cosmos. Like WASP-12b, it's a hot Jupiter, orbiting close to its star. But unlike its darker cousin, we don't have a complete explanation for its extreme lack of reflectivity. Its atmosphere is so hot that it should glow with a faint, dull red heat, like the embers of a dying fire or a hot piece of charcoal. But what light-absorbing chemical is present in its atmosphere in such vast quantities remains a deep mystery. TRES-2b is a puzzle, a world that challenges our understanding of planetary atmospheres, and reminds us that even in a universe full of light, there are places of unimaginable darkness. We end our journey with a world so spectacular it almost seems impossible. I must preface this by saying that J1407b is technically an exoplanet candidate. Its status is still being confirmed, but the evidence for it points to something truly magnificent. This super Saturn is a gas giant, or perhaps a brown dwarf, but its defining feature is a colossal system of rings. A ring system so vast, so enormous, that if it were placed around our own Saturn, it would dominate our night sky, appearing many times larger than the full moon. The rings of J1407b are estimated to span 180 million kilometers in diameter. That's more than the distance from the Earth to the Sun. There are more than 30 rings in this system, and they are so dense with material that we can see distinct gaps, hinting that exomoons may have already formed within them, carving out their own paths. It is a vision of a solar system in its dynamic youth, a celestial construction site on a breathtaking scale. J1407b may be unconfirmed, but it represents the sheer, jaw-dropping potential for wonder that still awaits our discovery. We have journeyed across light years and peered into the nature of worlds that beggar belief. A diamond planet, a world of glass rain, a planet older than our galaxy's spiral arms. And this is just the beginning. These 10 worlds are a tiny sample from the thousands of exoplanets we've already found, and there are billions more waiting to be discovered in our galaxy alone. For every bizarre world we've cataloged, there are 1,000 more whose strangeness we can't yet even conceive of. The universe has no obligation to conform to our expectations. What other wonders are out there? Are there planets with 2 different colored oceans, worlds where life thrives not on light, but on geothermal energy, in a sunless abyss? Are there planets that are not spheres at all, but some other bizarre shape, held together by forces we don't yet understand? The questions are as vast as the cosmos itself. The search for these worlds is more than just an astronomical exercise. It's a fundamental part of the human quest to understand our place in the universe, to know what's possible, and to continually expand our sense of wonder. So I leave you with this thought. The next time you look up at the night sky, remember that it is not empty. It is a grand theater of cosmic creation, filled with countless worlds, each with its own story. Which of these bizarre planets captured your imagination the most? Let us know in the comments below. And never, ever stop looking up. The universe is waiting.